All right, so we are going to be graphing sine and cosine and tangent, cosecant, secant, cotangent for that matter. But the main ones we're going to start with are sine and cosine. Those are the most common trig graphs that you will see. And so first, a couple of quick definitions. Period was defined in the last set of notes. I'll just write it again. So the period is the horizontal length of each cycle. Oops. Horizontal length of each cycle. Okay, so for example, let's go pink on these graphs right here. So a cycle, like this one for instance, let's say we start it right here. So it starts here, and then it goes up, it comes back down, goes down a little farther, comes back up, and then it's at this point right here where it starts to repeat itself. So from this point to this point, that's one full cycle. That is the horizontal length of each cycle. And so with this one, it happens to be 360, which we will write down in just a moment. The amplitude, this is not the formal definition that the book gives, but I think this one makes sense. I always call the amplitude the height of each wave. So that's like a quote-unquote wave, or like the peaks and the valleys, whatever you want to call these. So let's go orange for this. So the amplitude would be like this height right here. It's like that height, which if you're looking at this picture happens to be from 0 to 1, so that's a height of 1. You could also measure it this way, and that would be from 0 down to -1, so that would also be 1. So each wave is like from the center line right here, how high does each wave go, how low does each wave go, that's the amplitude. Depending on what sciences you've taken, you have probably heard of amplitude before. All right, so the first parent function, this is the sine graph. You saw it very briefly when we were looking at 12.6 in the last lesson. So the domain, these are values of theta. Notice this is the theta axis, not the x-axis. You can use any value of theta you want. Any value, any angle can be plugged into a sine function. So the domain is all reals. All reals, but remember these are values of theta that we're talking, not values of x. And with cosine, same thing. You can plug any value, any angle that you want into a cosine function. Range is what y values you get. A sine function and a cosine function are both periodic. They go up to a high point of 1, they go down to a low point of -1, back up to 1, back down to -1. Cosine starts at 1, goes down to -1, up to 1, etc. So both of them are only going from -1 to 1. So the y values, any y value between -1 and 1, but you won't go outside that range. So both of them are the same. So the y values are stuck between -1 and +1. Between -1 and +1. There's nothing higher, there's nothing lower. Okay? For this one, the amplitude, the height of each wave goes from 0 up to 1. That is a height of 1. Same thing with this, goes from 0 up to 1. That is a height of 1. In the period, it starts at 0. One full cycle ends at 360 degrees. So the period is 360 degrees. Same thing with this one. Here's the start of the cycle. It goes all the way down, comes all the way up, and then starts to repeat. So this ends right here at 360. Okay, so as every other type of function that we've done, we can transform them, we can stretch them, we can shift them, we can flip them around, all sorts of things. So trig functions can be transformed. So let me write kind of the generic. So here's just sine, just cosine. We can do y equals, you can put an a in front, and you can put a b in with the theta. Okay, so b and a are just numbers. So if you see down here, like b is 1/2, for I guess this is cosine. B is 1/2 here. Here, a is 3, and then b is 5. So we've got new formulas. Here, this is like the standard, run-of-the-mill, no changes made. The amplitude would be 1, and the period would be 360. If you throw in some numbers in place of a and in place of b, the amplitude is just whatever number you've got out front. That's a. So whatever number is right here, that's your amplitude. Notice you don't have anything here. That doesn't mean it's 0, that means it's 1. It's technically like 1 times the sine of theta. So that makes your standard amplitude 1. Here your amplitude would be 1. Here your amplitude would be 3. stretches it out by 3, so it's going to be 3 times as tall, which makes it 3 times as low. So instead of going up to 1 and down to -1, it would stretch up to 3 and down to -3. Okay, and then the period, you start with the standard period, which is 360, and then you divide it by whatever that value of b is. So here, b is technically 1. 1 theta, the period is just 360 divided by 1, which is 360. So let's get some practice with the amplitude and period. So this first one, the amplitude is still 1. There is nothing in front of the cosine, so you can technically think of it as being a 1. And then the period, you take 360 and you divide it by whatever's attached to the theta. So here you're dividing it by 1/2. Now, that is not half of 360. When you divide by 1/2, it's like multiplying by 2/1. Okay, multiplying by the reciprocal. So you get 720 degrees. So it takes 720 degrees to go through a full cycle of cosine. All right, important thing, this 1/2, what that number means is how many cycles the graph will go through in 360 degrees. So here, because there's just a 1, that means you'll go through 1 full cycle in 360 degrees. This means you'll only go through half of a cycle in 360 degrees, which is why it takes 720 degrees to go through the full thing. So hopefully that makes sense. Here with this next one, the amplitude is whatever number is out front. Here it's a 3. So that means instead of going up to 1 and down to -1, it'll go up to a height of 3 and down to -3. And then the period, same formula. What this one means is it goes through 5 cycles in 360 degrees. So you can consider it to be moving like 5 times as fast. Okay, so the original period is 360. Our formula tells us we just divide it by 5. And so divided by 5 leaves us with 72 degrees. Okay, so if it goes through 5 cycles in 360 degrees, that means it goes through a full cycle in 72 degrees. All right, so just a little intro here. So before we start actually graphing, let me write down what the patterns are, because sine and cosine each have their own patterns. We're going to talk about a 5-point pattern. Here's point, starting point, next, 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 and then the ending point, and that's when you start a new cycle. So there's a 5-point cycle, and it looks like this. We're talking about y values here. It starts at 0, then it goes up to its high point, so we're going to write h for high, then point 3 it comes back to 0, then it goes to its low point, L for low, and then it ends the cycle back at 0, and then that's where it starts to repeat. So 0, high, 0, low, 0, high, 0, low, so it just keeps on repeating. Cosine graph, point 1 is actually at the high point. Then for point 2, it goes back to 0. Then it goes down to the low point, and then back to 0. And then it finishes the cycle and begins a new one back at the high point. Okay, so if you have that pattern memorized, you'll know what a sine function looks like, you'll know what a cosine function looks like. Okay? And then any transformations that happen, you're still basically going off of the same curve. So let's flip and start to get some more details here. All right, so the theta intercepts, that's basically like your x-intercepts. So that's going to be where you cross, it's like here's your theta axis, here's your y-axis. So where you cross this axis, and if you look, this one crosses the axis here, here, and here, and then keeps repeating. This one crosses the axis here, and then keeps repeating. So this is going to seem kind of weird when I write it down, but I will walk you through it nice and slowly. Okay, so the theta intercepts. You get 0, 0, which I will show you. So see how it intersects at 0, 0, right there. The next time it intersects is right here. It's halfway through its cycle at this point. So we say half of its cycle, which is 360 divided by b, and then of course the y value is 0. That's what makes it an intercept. And then the last one is at the end of its cycle. So this third intercept right here is at the very end of its cycle. So whatever the value of the period is, that's at the end of its cycle, and then again the y value is still 0. And then the minimum and the maximum values, so here's your maximum value, that's a quarter of the way through the cycle. 90 degrees is a quarter of the way through. So the x value is a quarter of whatever the cycle is, and this is the formula for how long the cycle is. And then the high point is whatever the value of the amplitude is. Okay, so here the amplitude is 1, so it only went up to 1. If the amplitude was 3, it'd be all the way up at 3. And then the next one is at the 3/4 mark. 3/4 through the cycle. That would be this point right here, 270 on the standard graph is 3/4 of the way through. This is down at its low point. The amplitude is 1, this value is -1. If the amplitude was 3, that value would be -3. So it's just, for the y value, it's the negative of whatever the amplitude is. Okay, next, for a cosine graph. Cosine has two x-intercepts, right here and right here. 1/4 of the way through its cycle and 3/4 of the way through its cycle. Okay, so 1/4 of the way through the cycle. And then, of course, the y value would be 0 since it's an intercept. And then 3/4 of the way through the cycle. And again, the y value would be 0. Okay, and then finally, the min and max values. Here's the maximum value. The angle is 0, just starts at 0, and it's up at its maximum value. So the x value is 0. Its maximum value is a, just like it was here. Then, halfway through its cycle, it hits its low point. So half of the cycle, given by this formula, is at its low point, which would be -a. And then finally, the last point is at the very end of its cycle, it's back at a high point. So at the end, which is 360 over b, it'll be at a high point, which is a. Okay, so you don't really need to memorize that necessarily. It'll just really help you when you're graphing these patterns. So for this example, for part A, when you graph each function, you need to know 3 things. Thing number 1, you need to know what the amplitude is. Remember, the amplitude is just whatever number comes out front here. So the amplitude is 3. That means you're going to go up to 3 and down to -3. It's going to be stretched out. The period is 360 divided by b, which here is just a 1. There's nothing in front of theta. So it has your normal standard period. It goes through 360 degrees. And then we need to know what pattern we're taking on. So cosine's pattern, if you wrote this on the front page, cosine goes high, 0, low, 0, high. So the pattern goes like this. High, 0, low, 0, high. Okay, so here's how we start to graph. Set up a y-axis, set up a theta axis. Okay, we're going to use the period to mark up the theta axis. We want to go to 360. It's pretty standard to always go to 360. And then here's halfway through. Halfway would be 180. Quarter of the way through would be 90. We start at 0 right here. And then 3/4 of the way through would be 270. Okay, so that's how we mark up our theta axis. Those are the values of theta that we'll be using. 5 values altogether. And then we use the amplitude to mark the y-axis, how high and how low our graphs will get. So 1, 2, 3 will be our high point, and down to -1, -2, -3. Okay, so mark it up. The amplitude helps you mark the y-axis, the period helps you mark the theta axis, and then you follow your pattern. So first you are at the high point. So at angle number 1, you're up at the high point, which is 3, because that's my amplitude. Point number 2, you're back at 0, so that's right here. Point number 3, you go to your low point. So halfway mark, we go down to our low point, which is at -3. Back to 0 for point number 4, and for point number 5, we're at our high point, which is back up here at +3. All right, and then we connect the dots. Be very careful. Don't just make it like a giant V shape. You know what the cosine, it should be curved. So kind of start like a little to the left so you can see what happened before this. Come down, come back up, wrap around, and show what it's going to do. A little bit to the right and a little bit to the left. So this is one cycle. Starts here, ends here. Looks like the same cosine curve that we had on the front right here. Just gets stretched out a little bit. So it's got an amplitude of 3. Remember, that is this measurement right here. It has an amplitude of 3. And then it has a period of 360. So from this point to this point, it's got a period of 360 degrees. Okay, and then it follows the cosine curve. So let's look at a second one. This one, start with the amplitude. The amplitude is whatever number is out in the very front. So here it's a 1/2. It's attached to sine. So that means it's only going to go up to half a unit and down to -1/2. The period, you take 360 degrees and you divide it by whatever is attached to the theta. So here the period is just 180, half. of what the original period was. So that means we're going to go through 2 full cycles in 360 degrees. And then the pattern, since this is sine, you can take that off the previous page. Sine's pattern goes like this. 0, high, 0, low, 0. Okay, so let's start to fill everything in. So you draw a y-axis. Remember, we're going to use our amplitude to mark up our y-axis. And then here's our theta axis. So with theta, most of the time, we're just going to run it all the way to 360. 360 is pretty standard. So halfway in between that is 180. And this is 90. This is a pretty standard marking for the theta axis. Here, though, we need to see a full cycle starting here and ending here. So we need to get all 5 points. So your starting point is still 0. Your quarter mark this time is going to be 45. That's halfway between 0 and 90. And your 3/4 mark is going to be 135. That's halfway between 90 and 180. All right, so for my amplitude, if this is 1 and this is -1, remember you're only going up halfway. Okay, my amplitude is just 1/2. So let's graph those 5 points. So I start at 0 and I end at 180. Point 1 is at 0, so I start right here at 0, 0. Then I go to my high point. My high point is just right here, only half a unit up. Then back to 0. Then down to my low point, just half a unit down. And then back to 0. So that's one cycle. So the period is 180, so that means my first cycle is over. I would do another full cycle before I land at 360. All right, so I'm going to go through, follow this cycle. Here it goes. And then we go through another full cycle before landing at 360. Okay, so my amplitude is just half a unit right there, just a little half unit with the amplitude. And then my period starts here, ends here, and that is 180 degrees. And then we're following the standard sine curve. Okay, let's flip and let's very, very briefly look at how to do the other types. So the next type we're going to look at is tangent. Tangent is much less important. We're going to do a lot less work with it, so I'm just going to kind of breeze you guys through here. Tangent looks like this. It's a crazy graph. So every time you hit -90, 90, all of that stuff, tangent is defined as x over y, and some of these values are going to be 0. So first, our domain, you cannot plug in a lot of different values. So starting with 90 degrees, that's the first value that you get an asymptote at, like this, and then every 180 degrees after that, you have an asymptote. Okay, so don't worry a ton about this. We're not going to do a ton of work with tangent graphs, but I just want to introduce you. The range is all reals. All values, sorry, that's the symbol that means all reals. I think you've seen that before. So it keeps going super high, keeps going super low. There's no limit for that. The amplitude is undefined. The amplitude goes on forever. Goes super, super high, super, super low. You don't really have waves like you do with sine and cosine. And then the period is 180 degrees. So like from here to here, that's one full cycle, is this little wiggle right here. So from 90 to 270, or from -90 to +90. And the theta intercepts. In one cycle, we intercept at 0, 0. And so that is right there. And then if we kept going, and by one cycle we mean in 360 degrees. Okay, so in 360 degrees we'll see that one, and then halfway through 360 we'll see another one, and then at the end we'll see another one. Okay, so something like this. So the next one you would see would be halfway through, so 1/2. So like here it's at 180, and then the last one would be at the end. Okay, again, don't worry too much about these. This is just kind of guide you through to see like, oh, here's one, and here's one. Okay, and then the period, amplitude, and asymptotes. These ones are weird to look at. So the period is always 180 divided by b. And then the amplitude, still don't have any. The amplitude is technically undefined because it can go as high and as low as you can possibly imagine. And the asymptotes, this is kind of weird. Asymptotes are odd multiples of 90 over b. So again, I don't want you guys we're not going to do a ton of work with tangent. Like I said, we're just very, very briefly introducing you to the other 4 types besides sine and cosine. So this one, The period, since there's no change here, there's nothing in front of the theta, the period is, 180 divided by b, which is just 1. There's just a 1 technically in front of that theta. So let me write more carefully here. So the period is just 180 degrees. So really the only thing that's going to happen with this, since you can't really change the amplitude, all it's really going to do is kind of stretch it. It's going to look very similar to the normal tangent graph. So the amplitude is still undefined, kind of goes on forever. And then the asymptotes, I know it's weird when it's worded as the odd multiples of 90 over b, but it looks something like this. So 90 over b would be 90 over 1, which is 90. And so you take odd multiples of that. So like negative 1 times 90, for instance, would be negative 90. 90 times 1 would be 90. 90 times 3 would be 270. Etc. So you don't take 180 or 360 because those are even multiples of 90. We just want to take 90 and multiply it by odd numbers. That's what this definition means. So here's how we set it up. Okay, so we're going to make the theta axis a little wider because we do see what's going on to the left in that graph up above. So we're going to have asymptotes. So here's negative 90. That makes this 90. Here's 180. Here's 270. And it just kind of repeats. Okay, so we have asymptotes at the odd multiples. So here's one, not here, but then again here, not here, and then again here, not here. It just kind of repeats itself. All right, and then we mentioned up here the x-intercepts. So basically, at each other multiple of 90, you'll have an x-intercept. So you'll have one here, you'll have one here, here, and it'll just kind of repeat. So let's draw in another asymptote to kind of guide this one here. And then it basically just looks like this. Kind of wiggles up to this point, and then just glad to see you've got a piece here, piece here, and it just repeats this pattern just over and over and over again. It's not a super exciting graph. The only difference from graph to graph is where the asymptotes are basically. Okay, so that's a very brief look at the tangent graph, and now an even briefer look at the other graphs. So remember, cosecant, secant, and cotangent are reciprocals of the other ones. So the way they're related is that they are reciprocals of the sine, cosine, and tangent functions. So here's the part that's super weird. See here, like here's your typical sine function. Anytime sine is 0, the reciprocal of 0 is 1 over 0, which is undefined. So the reciprocal of 0 is something undefined, which turns into a vertical asymptote. So that's these dotted lines here. Same thing here. Every time cosine is 0, the reciprocal of 0 turns into an asymptote. And then same thing here. So this dotted line is tangent. The reciprocal of tangent basically ends up weaving the other way. It still has asymptotes where tangent has asymptotes. So this, you're never going to have to memorize any of these values. The amplitude is all undefined because they all just go up forever and down forever. Cosecant and secant have the same period as sine and cosine. And then cotangent has the same period as tangent does. So just very briefly, we're going to tackle one of these. So cosecant of 2 theta, for the period, you do it the same way as you would do with sine. For the period, you take 360 and you divide it by 2, so that's 180. So the best advice I can give you for these is to kind of sketch out what sine is supposed to look like. Then you can use that to graph cosecant. So let's start here. So we're going to sketch what the reciprocal function would look like. Okay, so we'll do that very briefly. Okay, so here's your theta axis, here's your y-axis. Remember, we usually go all the way out to 360. So halfway between here, this would be 180. So that's where one of your cycles is going to end. Then 90, 270. And then we mark here. This is 45 because this is going to be a quarter of the way through our cycle from here to here. And then this is 135. So we are just going to sketch the sine graph. All right. The amplitude is just 1 because technically there's a 1 in front of here. So up to 1, down to negative 1. So the sine graph, remember the pattern goes 0, high, 0, low, 0, and then it would repeat. So I'm just going to do a little sketch, just so you can see it, and then it repeats itself, just like that. Okay, so two things. First thing, wherever sine is equal to 0, its reciprocal will have a vertical asymptote. Okay, so in all of these places right here, whenever sine is equal to 0, cosecant will have an asymptote. Okay, because 1 over 0 is undefined, so we draw it as a vertical line. And then like here, the reciprocal of 1 is 1, so they actually share a point right here. Same thing right here. And the reciprocal of -1 is -1, so they share a point here, same thing here. And then what they do is they just kind of, like they take this piece, and it's like they flip it upside down and kind of glide along those asymptotes. So right here, same thing here, take this piece and flip it upside down, because they're the reciprocal. Same thing right here. See, like the fraction just kind of looks like the same fraction just flipped upside down. The graph looks like the same graph except flipped upside down. So all these individual pieces, that's a cosecant graph. All right, so just a very, very brief introduction on those. You need to know a lot less about those than you do about the sine and cosine graphs.